Alright friends, hello and welcome to Physics 365, where we are doing physics every second of every day. I'm your host, Eli Hibbett, and how are you doing today? The 5th of February, 2016, a Friday. And on this day in physics, we say happy birthday to Robert Hofstadter, an American physicist and winner of the Nobel Prize in 1961. He shared the prize with Rudolf Mössbauer, however they won for separate contributions. According to the Nobel Prize official award, the Nobel Prize in Physics 1961 was divided equally between Robert Hofstadter for his pioneering studies of electron scattering in atomic nuclei, and for this thereby achieved discoveries concerning the structure of the nucleons, and Rudolf Mössbauer for his researches concerning the resonance absorption of gamma radiation, and his discovery in the connection of the effect which bears his name. So, there we go. One half of the Nobel Prize winning duo there. We're not going to focus on Rudolf Mössbauer. We're just going to say happy birthday to Robert Hofstadter. And yeah, let's take a look at the word of the day, centripetal acceleration. And what, dare I ask, is that? Centripetal acceleration is an inward acceleration experienced by an object experiencing curved or circular motion. So, consider F equals ma. Force is equal to mass times acceleration. So, we have examined in two previous words of the day what mass and acceleration are. So, if we have an object of constant mass and it starts to experience curved motion, the velocity is changing all the time because the direction of the vector is changing. The direction of the velocity vector. In circular motion, the acceleration is always pointed radially inwards, towards the center of the circle. The force generated by this acceleration is known as centripetal force. Many people confuse this with centrifugal force, the word of the day yesterday. Now, imagine you are driving a race car around a track about to take the first half-circle curve. We know the radius of this circle and can read from the speedometer the speed. The centripetal force can be calculated as F equals mv squared over r, where m is the mass, v is the velocity squared, and r is the radius. So, the force is dependent on the radius of the curve, because this defines how tight the curve is, and how fast you're going, the mass of your car. I'm going to go a little off script here. So yeah, the radius, changes how quickly you're accelerating. So of course it's going to change the force. So let's go. Let's dig back in. Now, a body moving wants to travel in a straight line, so there must be an unbalanced force in order to create the circular motion of your car. What gives this force is the friction between the tires and the track. This friction will only sustain a car going in a circle up to a certain velocity for a given radius of curve. After that, the car will begin to move in a straight line again, and is what causes cars to skid on curves. So, that is centripetal acceleration and centripetal force, the force pointing inwards, which causes the circular motion. So, yeah, we got centripetal and we got centrifugal. Centrifugal is a false force pushing outwards, and centripetal is a force pushing inwards. So, with that in mind, let's revisit the quote of the day yesterday. The fact that mankind persists shows that the cohesive force is greater than the disruptive force, the centripetal force greater than centrifugal. So he's pretty much saying the same thing twice. The centripetal force pointing inwards, pulling people together, is greater than the centrifugal force pushing people outwards. So very cool guy, and using a little bit of scientific jargon there. So good on Gandhi. So that's going to do it for today, guys. Episode number 36 of Physics 365. Head on over to pwnphysics.blogspot.com for resources, blog entries, links to the other podcasts, links to apps on the Apple iTunes Store, and more. We hope to see you over there, guys. And if not, I'll see you tomorrow. Take care.